In the previous example, we solved for theta when we were given a trig ratio by hand, but we could only do this if the angles were one of the special angles. So 30 degrees, 45 degrees, or 60 degrees, or likewise pi over 6, pi over 4, pi over 3 if we're using radians. So what if theta isn't one of these special angles? Then we need to use our graphing calculator. And I'm going to show you how to do that now. In the first three examples, letters A through C, we're going to solve for theta in degrees on our calculator. And in the last three examples, we're going to solve for theta in radians. So in example 6a, we're told that sine theta equals 0.95. So we want to find the angle who has a sine of 0.95. So in order to do that, we need to undo sine theta. So in the past, when we want to undo a function, we use the inverse function. So that's what we're going to do here. We're going to use inverse functions to undo the given trig function. So if I want to undo sine theta, I can take the sine inverse theta of both sides. So I'll have sine inverse of sine theta on the left side is equal to sine inverse of 0.95. Now on the left side, sine inverse of sine, those undo each other. And so we're left with theta is equal to sine inverse of 0.95. And now we're going to switch over to our calculators. So I'll share that screen now. And let's see how we can do that on our calculator. So if you hit the trig button, you'll see that we actually have the sine inverse function. So we can hit sine inverse and then 0.95. But before we do that, we need to be careful because we want the angles to be in degrees. And right now, this calculator is set with the angles in radians. And when you use inverse trig functions, the angles will always be whatever mode, they'll be determined by the mode of your calculator. Unlike when we found trig ratios given an angle, we could force the angle to be in the units we wanted. For trig functions, for inverse trig functions, we have to set the proper mode. So for letters A through C, we want it to be in degrees. So I'm going to convert this to degree mode. And now I'm going to hit enter. And we find out that the sine inverse of 0.95 is 71.8 degrees. If we were in radians and I did this computation, I would find out that is sine inverse of 0.95 is 1.25 radians. So for the first three calculations, we want to be in degree mode. So I'm going to leave the calculator there. Okay, let's jump back to the notes. Okay, so we just found out this angle was 71.8 degrees. So I'll write that down. 71.8 degrees is equal to theta. In the next problem, we're told that cosine of theta is 0.7142. To undo cosine theta, we're going to use inverse cosine. So I'm going to take the inverse cosine of both sides. So inverse cosine of cosine theta is equal to inverse cosine of 0.7142, or cosine inverse, you could say it in either order. On the left side now, the cosine inverse of cosine theta, that undoes the trig function, leaving us with theta is equal to cosine inverse of the ratio 0.7142. And so using cosine inverse, that will give us the angle that has a cosine of 0.7142. So we'll jump back to the calculator and we will determine what that value is. So I'm going to hit the trig button. I'm going to choose cosine inverse. And now I'm going to type in 0.7142. I'm going to confirm that my mode is in degrees. So that will tell me, that will give me an angle for this problem in degrees. So I'll hit enter and I got 44.4 degrees. So we'll go back to the notes. We'll write that down. And then we'll go on to the next problem. So theta here is equal to 44.4 degrees. I think you're starting to see the pattern here. If we want to undo tangent theta, we can use the inverse function, which is tangent inverse. So I'm going to write tangent inverse of tangent theta is equal to tangent inverse of 12.71. And on the left side, tangent inverse of tangent theta undoes the trig function, and that leaves us with that theta is equal to tangent inverse of 12.71. Let's go back to the calculator and find out what that value is. So we're going to hit the trig button, choose tangent inverse, type in the ratio that we're given, 12.71. We're still in degree mode, hit enter, and that tells us that the angle whose tangent is 12.71 is 85.5. Trying to get this to link up with the notes again. Okay, so here we got theta is equal to 85.5 degrees. For these next three problems, let's do all the work in the notes, and then we'll do all the computations on the calculator. So we don't have to switch back and forth so much. Okay, so now we're doing reciprocal functions. What about them? We can still use the inverse reciprocal functions the same way to undo them. So we have cosecant theta equals 1.95. To undo cosecant theta, we can use cosecant inverse. So we have cosecant inverse of cosecant theta is equal to cosecant inverse of 1.95. Trig functions on the left undo each other. That leaves us with theta is equal to cosecant inverse of 1.95. Let's do the next one. So secant theta, to undo secant theta, we can use secant inverse. So secant inverse of secant theta is equal to secant inverse of 1.461. And that leaves us with theta is equal to secant inverse of 1.461. And for the last problem with cotangent, we can undo cotangent using cotangent inverse. So cotangent inverse of cotangent theta is equal to cotangent inverse of 2.613. And now the left side, the trig functions, inverse function, cotangent inverse undoes cotangent theta. So that leaves us with theta is equal to cotangent inverse of 2.613. So now I'm going to go over to the calculator and we will do all three of these calculations right now. So first problem, letter D, we have to do trig cosecant inverse. So cosecant inverse of 1.95. But now I wanted these angles to be in radians, and our calculator's in degree mode. So if I just hit enter here, the angle will be in degrees, but we need it in radians. So let's switch to radian mode and hit enter. So the first answer in the set of radians 60 is 0.538 radians. We'll do the next one. So trig, hit secant inverse. So secant inverse of 1.461. Our calculator is still in radian mode, so I'll just hit enter. So that gives us 0.817. And the last trig function that we want is cotangent inverse of 2.613 and hit enter. And that angle is 0.366, rounding to the nearest thousandth of a radian. And I'm just going to switch back to the notes and we'll go ahead and enter those angles. So here, theta is equal to 0.538. I'm going to write radians, but you don't need to. If there's no units, remember the units are radians for angle measures. theta is equal to 0.817 radians. And the last problem, we got theta was equal to 0.366. So if I don't write any units, once again, that is in radians. Oh, I just realized that my writing didn't record. So you heard me talking, but didn't see it. But here you go. I've written everything down here. You can take a look. Okay, that's the end of this example.